Hi, my name is Steve, and in today's project, I'm going to take you through a new 3D printer that I've just purchased. This is the Anycubic Vyper 3D printer. I'm going to go through a quick unboxing and installation and setup. Just going to do a lapse time video of that. There's lots of other videos out there that you can get a little bit more in depth if you want to see the true everything in the box and the complete instructions on how to set it up. I have the Anycubic website up on my computer while I'm going through this. I've got a lot to cover in this video, so I will have timestamps down below along with links to everything, because I want to go through, once everything is put together, the first print, and take a little bit more time beyond just the setup. So for now, we're just going to move on to the time lapse. So now that I've completed the build and started reviewing all of the different setup configuration, checking all of the rollers to make sure everything works correctly, is tightened. Everything was very well done from the factory. Really haven't had to do anything with it. The one thing I noticed, and this isn't an issue from the factory, this is when I was putting it together trying to follow the instructions, is this cable connected to the printhead assembly along with the PTFE tube. But what I don't care for, one, when it goes all the way over here, fine, it's tightened, but as it comes back, I started to notice that this starts dipping down. And as that dips down, if you've got something on the bed, it could hit this. What I'm going to do, simply disconnect this. I'm just going to route this now on the underside instead of the top. So that puts the cable on the top of the PTFE tube. That now going back into here, and that keeps this elevated a little bit more. One other thing that I noticed on this side of the extruder, they have and I'll put one of these up here, hopefully that'll show up, a PTFE tube kind of holder. So keeps the PTFE tube mount pulled out so that the tube doesn't pull when you're pushing your filament through it. So if you have some of these, I would add it to this one. If you don't, you can purchase them. They're extremely inexpensive. You could even 3D print them. And I'm just going to add that onto here. So that did not come with the kit. I had one of those from a previous 3D printer. So now that we have the unboxing and build completed, we want to do a couple of things. So first, we're just simply going to power on the device and let's see if we've got power. So I did have to change the voltage from 230 to 115. It should be 220 and 110. The next thing I want to do, so the screen comes up, everything powers on, appears to be working. I'm going to go into the system menu and the about. What I want to check is the firmware. So if you go out to the Anycubic website, you can download the latest firmware, and this is not current. So what I'm going to do is you'll need two things. I'm going to turn the power back off. So one, you are going to need a SD card for the main board firmware update, because the card slot on the main board on the main 3D printer is an SD card. There's also firmware for the screen. So we're going to do a screen firmware update, but for that, on the bottom of the screen is a micro SD card. So you do need two different cards to do the firmware. Okay, so it appears that we got the first firmware update. We'll take a quick check here. 2.45, so the firmware update on the machine finally worked. I did find a YouTube video from, I'll put a link in the description to give the person credit, because what they found was the only way, it appears, to get the main board firmware update completed is to use the actual card that came from Anycubic with the 3D printer. The other card I was using, I tried different formats, it didn't work. When I copied the files off of this card so that I didn't lose them, I deleted everything from the card, put the main board file on it, and as you can see, that now worked. So it appears to get the firmware update, you need to use the card, the SD card that came with the printer. Now we'll see if it works for the screen. So that completes the screen firmware update. You just turn off the power and that should be completed. So another option as a recommendation, you might have something like this or you can purchase something, but this is a micro SD card extender. I had a lot of problems trying to get the little micro SD card in. It's inset a little too big. The opening's too big, you might lose it, so that was a bit cumbersome. Now it's in place. This now becomes where you can insert your micro SD card, but if you have one around, I would highly suggest it. So the next test I want to do is going to be the filament runout sensor, to make sure that that's working, as well as the power off resume function, to make sure all of that is working the way it's supposed to. So I've just got some of the filament that they provided. I'm going to put this through the sensor. I'm not going to feed it through the extruder. I'm just going to leave it hanging out so that it detects filament in there. I've set up a model for it to start printing, even though there's no filament. So I'm not going to print anything. I'm just going to trick the printer. Once it gets started, I'm actually going to do the power off test. So I've just plugged the printer into a power strip so I can turn the power off while leaving the printer turned on. We'll see if it allows me to then resume the print. After that resumes, I'll pull out the filament and make sure that the sensor is detecting that. We'll give it just a second here, let it go through a few motions. And we'll turn off the power. Put the power off. Give it a second. Power it back on. And we get the tips. It's telling me that there was a power outage and I am allowed to continue. Everything will have to heat back up, so we'll give it just a minute to do that. And it will rehome. And now it will resume the print. So the power off worked. Now that that resumed printing, we are going to pull out the filament. You get a warning. Filament is out. We hit OK. We put the filament back through. We'll hit resume. And it resumes. So both of those are working correctly. The final test I want to do before I actually get to printing my first 3D printout is test the extrusion. So I want to make sure that the extrusion is set up to properly output the correct amount of filament. I wanted to check that this was set up properly by the manufacturer. So in order to do that, again, I'm going to disconnect the PTFE tube because I don't need to extrude it through the actual printer at this time. I'm going to take the white filament that they provided, get that feed through the extruder, let everything come up to temperature. We'll feed this through. I'm also going to then be connecting this printer using the USB cable that was provided onto my laptop. I'm going to use my slicer application to connect, and that will allow me to control the extrusion. And we're just going to test to make sure we get 100 millimeters output and the steps are accurately captured. So for this, we're going to need a magic marker to mark the filament, and then some calipers to measure how far it extruded. So I'm simply going to take and mark this right at the output. We're going to extrude 100 millimeters of filament. And let's measure what we get. We're at about 97 millimeters. So just a little bit under, but I would say pretty close. Not sure if I'm too worried about making any adjustments off of that. So we're going to leave this as is. We're going to get ready to do our first print. The next step I'm going to go through is the auto bed leveling. That was recommendation in the manual, so we're going to follow that. So we're going to turn it on. Go into our menu for prepare, leveling, auto leveling. It's going to ask me to use a tool to make sure that that nozzle is working, so I just press the nozzle, calibration success. Amazing how quiet the Z stepper motors are. The loudest part of this printer is the fan, so this will take us through 16 steps on the bed. You do not have to auto level all the time. You don't have to do this before every print. You really kind of do it once, and unless you change the nozzle, if you do something where maybe you move the printer or have done something that you're making a change within the printer itself, then I would run the auto leveling. So it's preparing the machine. It's heating up the nozzle or the heat bed is going to 50 degrees, the nozzle 170 degrees. So you want to make sure you're below 50 degrees Celsius on the bed, below 170 on the nozzle. Then you can run the auto leveling. If you're above those, I would let it cool down to below that before you run the auto leveling. Okay, now that that is completed, everything should be done. Now, one of the things I did notice is you can see all the white dots on here from where the nozzle went down. The reason for that, I have not done anything with this 3D printer as far as loading any filament. So I have not done anything as of yet, have not done a print, but these are tested by the manufacturer prior to being shipped. So that tells me there is filament in the nozzle that when it heated up was extruding just slightly onto the bed. So it does tell me they did test this before they sent it. So that's not necessarily a bad thing, but I'm hopeful that also does not throw off the bed leveling, because that little bit of plastic in between on the nozzle could cause it to not be 100%. So we'll see how it does when we get to our first print. So now that I have everything all set up, gone through the testing that I wanted to do, we're ready to finally do an actual 3D print. What I'm going to do is initially two different prints. I'm going to print the owl directly off the SD card from Anycubic with their Cura settings. I personally don't use Cura. I have Simplify 3D. So Simplify 3D also offers a default setup for the Anycubic Vyper. So we're going to do the owl with the Anycubic default model. I'm going to take the STL file off the disk, output the Simplify 3D recommended settings, and we're going to see how each one of those performs. So there you have it. Anycubic Vyper. A few reasons why did I purchase the Anycubic Vyper over some of the competing 3D printers in this space. For me, this is a third 3D printer that I've owned, so I've gone through a lot of mods and upgrades and tearing 3D printers apart, building them together. I really wanted an all-in-one, out of the box, really very little that I have to do to make any adjustment. When I looked at some of the competition, looked at the Ender, 3 line of products, to me, those were more for being able to really great machines to learn on, great machines to mod, take them apart, really learn all the inner workings of a 3D printer. But I didn't want that. I've already done that. I wanted something that had auto bed leveling. I like that this has the pressure sensitive bed leveling versus something like a BL Touch. So I looked at a artillery, Genius Pro, which was direct drive instead of the Bowden. Direct drive wasn't as critical to me. I have another 3D printer that I've modded to have direct drive, so this gives me one of each version, so I was okay with that. Really impressed, just out of the box, ready to go, let this thing run. So for me, that's the reason I went with this. You have to decide, what is it that you want to do with your 3D printer? Are you trying to learn? Do you just want something that runs and you don't have to do anything with it? So there's always variations to why you pick what model you would go with. I hope this was helpful. If you liked it, please give it a thumbs up. Subscribe if you want to see more. Feel free to leave any comments if there's something I missed or something else you'd like to see, and get some more information on this 3D printer. Thanks.